Now we're going to look at the relative velocity. If I had the velocity of an object A and it was relative to the velocity of an object B, then what I'm saying is, what is the velocity of A as seen by B? So say if it was two ships, if I was ship B, what is A's velocity that I can see from ship B? And that is equal to the velocity of A take away the velocity of B. An example of that would be if I was given the velocity of some ship A and it was 7 minus 2, and the velocity of some ship B and that was 3, 4, then the velocity of A relative to B is equal to 7 minus 2 take away 3, 4, and that is equal to 4, negative 6. But what does this mean? Well, diagrammatically what it means is that if I have a particular object A, so it has a position vector A and it has a velocity, and also I have a particular object B, so it has a position vector B, and it also has a velocity. For me to be at B, observing the motion of A, I need to say that B is stationary. And to make B stationary, I need to apply an exact negative velocity on B. So therefore, theoretically, stopping B in its tracks. What I do to that object B, I must also do to the object A. So I also apply the negative velocity of B onto A. I now can determine a resultant velocity. And that resultant velocity is this velocity of A relative to B. And so that's from the sum of vector A plus the negative vector of the velocity of B. And if you can see, that is basically what I have here. That the velocity of A relative to B is equal to the velocity of A vector plus the negative of the velocity of B.